Welcome back guys to the channel. So in this video we are going to take a look at a data set in which we are going to predict a person is suffering from a heart disease or not. Okay, so you can get this CSV file from my GitHub and you just have to get it on your desk, and we are going to initiate this command and we are ready. So first we are going to import pandas and matplotlib. So we are going to read it by pandas and we are going to convert it into a tabular form so that we could easily understand. The parameters given are, we can just get the parameters like here, like this also. Heart, I'm going to print heart, then colon COLU columns. This is the way we can get the all the parameters like this only. Okay, yeah, we get this. So first we have age, then the gender, then chest pain, resting, and these all are the parameters. Okay, we have to predict the person is suffering from a heart disease or not. So let's see what are the basic parameters inside it. What is the age? Means how much variation, like 40, 50. Okay, so no, like, let me explain you like this. ST slope na, if you'll see ST slope here, it gives 3. That means there are 3 unique parameters in which it is defined. Okay, so we can get this by using this NU n unique. That way it will give me number of unique entries in the following data set for the following parameters. Okay, so yeah, here you can get this, and there are basically, if we'll see the size for the data set, so let's see what is the size dot shape. So 918, that means there are 918 there is entries with 12 parameters. Okay, yeah, so let's see our data set is clean or not. We're going to use the same. Is there any NA in our data set? So yeah, there is nothing, hence we are just ready to go with this. There is no NA, and yeah, what we can see here in our data set, there is so much these alphabetical values are there, normal, ST and all, ATA and NAP. Okay, so we have to convert it to a numerical form so that our computer will be able to understand it. So what we are going to do is we are going to create dummies for this. We are just going to do this like this, pandas dot get dummies. It is going to get dummies for each of the following, and heart, we are going to use the heart data set, and drop first, it is going to drop it, and it is true. So what you can understand here is we are just simply converting the alphabetical values into a numerical one by basic. If there are binary, like in gender we have binary 2, we'll see 2, so it is going to convert it into 0 and 1. And if we have a 4, like in chest pain, it is going to give it 0, 1, 2, 3. Okay, like that it is going to convert it for the following data set. So what we are seeing here, we have converted it, and this is what we get in the end, and we are all set for it. Yeah, so see how it is converted. It has not taken 0, 0, 1, 2, 3. It has basically converted into 0 and 1 only, binary. So what it has done here is, like we are talking about the chest pain. So chest pain, we'll see the, yeah, ATA NAP. So it has done here is, it has taken chest pain, and for that ATA it has given 1 if it is true, and if it not, it has given 0. For the following NAP also, it has given 0 and 1. So it has converted the whole data set in like these components only. Okay, of binary 0 and 1. So we are all set by using the dummies variable. Our numerical, our alphabetical values are converted to a numerical one, and we are ready to go. So let's train it. Yeah, first we have to classify it, that we are going to predict the heart disease. So we are going to drop it, and we are going to get this FDF set, which is our set for parameters, and ERS parameters. And the second one is target, that we have to predict this one. We are going to import test train, and we have given 20% in test and 80% in training. So first we are using the linear regression model. Let's see if there is any linear relationship, or it let's see how it is going to predict. behave for this linear regression. Okay, we have imported linear regression from linear model. Linear regression we have initialized it by L model, then we have fitted the X train, Y train, and we get accuracy of 55%, which is not good. Okay, let's try something else. After this we are going to yeah, for increasing the accuracy we can do this thing also by standardizing the data. So we are going to take it from sklearn processing, and we are going to import the standard scale. So we are going to scale the data according to our data set, so it is scaled, the data is scaled, hence it will be easier for our machine learning model to get prediction, and it will be much more efficient also. Okay, so we have scaled our data. Yeah, so after that linear regression we are going to use the random forest. So random forest, it is giving us 86%, almost 86%. We have just given the same argument but with random forest it is giving us 86, which is considerably very good, very good. So yeah, in the previous video I have discussed about random forest, so if you have not check that out, so you can do that also. Okay, very beautiful diabetic model we have created there. So yeah, we are going to now use a PCA. What is it? So PCA is a means an operation which only takes specific percentage of data. We like when you are going to study, when I'm going to get this the data set for digits, then it is going to be a greater significance, because sometimes what happen is a particular segment of data is much more important than the other one, and for that we are using this only. So it is going to take the 95% data which is actually very useful, and going to remove the other 5%. Let's see how it classifies that also. Okay, so what we have done, we have taken PCA, we have taken 95%. You can take it 90, 80 depending upon your so it basically helps us to reduce the time for computation, and makes the our model reduce its accuracy, but the time consumption and the computation power is reduced. Okay, so it helps in that, but the accuracy is also reduced, accuracy also fell down. Like we are getting 86% for this now. If you are going to employ the same model with the 95% data only, like extrain PCA, that it is reduced 90%, so it is going giving us 70%, but the computation time is reduced. So when you are going to handle some big data sets, it is going to be very helpful. But for now we can see that accuracy has been decreased. Okay, so yeah, this is like this only. So yeah, we can perform cross validation to just let's try something new, means new model. So we are using the decision tree here, and going to initialize it with cross validation of 5. You can change it according to 10, 15 and 20 according to your will, and depends upon you. So here is the array of scores we are getting for each successive epoch, and it is giving us 75%, which is considerably good. Yeah, it is good, it is good. First we have 55% from linear regression, then random forest give us 86%. Yeah, 86%. So random forest is best, because it a combination of decision trees and all. Okay, it is performing very well, and performing cross validation here also it is giving 82%, which is reduced, but still it is good, because it is going to predict us good values. So yeah, yeah, after that we have given the bagging classifier, and it is giving us 78%. So here we have almost used 3 to 5, 5, 5, almost 3 to 4 to 5 machine learning models, and we are getting the accuracy of about 70, 75%. Okay, if we'll take the mean for all of them, we are getting accuracy for that only. So yeah, this is all for this video, and we have employed some great machine learning models here also. And yeah, in the coming videos we are going to take it to StroML basically. Okay, this is just the basics of machine learning that we are going to take it, that how we are going to classify data, how we are going to manage it. So we are going to see in the machine learning videos, but our main aim is to get mastered over StroML. So it may be started in month of July. I'm going to start in July, and yeah, so just keep this in check, machine learning in check, so that we could just directly move to this STML after doing all of these basic data sets from machine learning. So yeah, this is all for this video, and yeah, let's see you in the next one then. Thank you.